Welcome to session 4 of the 2023 National Weather Service Milwaukee Sullivan's spotter training session. And this session, we're going to talk about radar interpretation and how you can use this to help with your decision making when it comes to storm spotting and where to be. So, one of the main things we like to talk about is just, again, the ground truth that we get from storm spotters is incredibly important to the severe thunderstorm warning process and letting people know what kind of bad weather is headed their way. The radar is again a great tool. We can tell a lot from what's happening with the storm from the radar, but one of the issues we run into is that we are typically not scanning the lower parts of a thunderstorm unless it's extremely close to the radar. Normally, we're at least 1,000 feet above the ground or higher when our radar is looking at the storm. So, depending on how close it might be to the radar, what direction it's going, we can see different things. But again, the spotters provide us with that ground truth of what's actually happening with the storm. We don't see the weather that's actually occurring, we see things that are happening with the storm, and we're interrogating what we think is happening. So what happens is the radar sends out a pulse of energy, and then it sits and listens for that energy to get reflected back to the radar. So however long that takes for that energy to go out, and then however much of that comes back to the radar, tells us what's going on at that spot. So there's a lot going on, but we're able to see quite a few things. So again, one of the issues is just where the storm is and the location. So we're going to use the Oconomowoc thunderstorm from last year where we had a ton of hail and just kind of show the different things that we run into. So our radar doesn't just do one scan. It does one lower level scan, it goes up a little bit, does another one, and then it's almost up straight up and down before it finally stops and goes back down to the ground and does more scans. But we see different things based on where that storm is. So this one was pretty close to the radar, so we were able to see a lot of the lower part of the scans, as well as from Green Bay, we were able to see more of the top parts of the thunderstorms when that storm occurred. So here's a snapshot when that storm was sitting over northwestern Waukesha County. You see all the bright pinks and whites and purples there. There was a lot of hail that was falling. So depending on where you're at, Milwaukee radar in the south, the Green Bay radar to the north, really good resolution, a lot of things going on, but we're not able to see what's happening 30,000 feet and beyond that for where, how tall is this thunderstorm? That's an important aspect when it comes to trying to warn on severe thunderstorms. So that's why we typically rely on looking at Green Bay or La Crosse or Davenport or Chicago to get another view on what's happening with that storm. So you can see from the Green Bay radar, there's some heights that are pushing 40,000 feet with some of the raindrops and things that we're seeing in the thunderstorm there. So the common thing of just telling you how much stuff is out there is reflectivity. So the brighter reds and yellows on this screen are telling you that, hey, there's quite a bit of rain that's happening there. It's just telling you how much stuff there is. So the other one is velocity. This is the other main field where we can get a gauge on if there's rotation with a storm. It's the Doppler effect that we're using here to gauge whether or not there's rotation. So it's like if there's a police car with its siren going and coming towards you, that sound wave sounds different when it's coming towards you than when it's going away. So we paint anything coming towards the radar as green and anything going away as red. So in this example here, this was by Toma last year. We had a rotation where you had these very, very strong rotation, these bright oranges going outwards and then some green coming in. So that's just showing you that there's rotation there. So that's one of the things we look at when we're trying to figure out where a tornado potentially is and how strong it is as well. We have something also called storm relative velocity, which is just subtracting out the storm motion. So we're able to lock onto a storm and see what the movement is, and from that it subtracts out the storm motion and makes the rotations a little bit more obvious. So if you're trying to look for that, that's something you can look for. So there are a bunch of different things that show up on radar that we interrogate to get a sense of what's happening with the radar or what's happening with the actual thunderstorm. So here is again from The Green Bay radar, there was something called a three-body scatter spike. This is just a big wet hail signature for us. We know when we see something like that, there's likely a lot of hail or at least some large hail that's occurring there. Hook echo, this is where you have rotation within a thunderstorm and you're getting that warm, moist air off the ground, getting wrapped up into the thunderstorm. You get this, it looks like a dry area, but it's just um, warm air from the ground wrapping in, and you get this hook look to it, like right here. Typically, this is where the tornado would be if the environment was there for it. Outflow, that fine line. So imagine you have this big mass of heavy rainfall that's coming through that's got a widespread area of all that cold air coming down to the ground. You're going to get this fine line where that colder air is going to be pushing through. So you can kind of make it out here. A lot of times, if you loop your radar, you'll be able to see it. You can get some gusty winds with that first surge of the wind coming through, so something to just be aware of. A bow echo, so when you have a situation like the Northwoods blowdown here, something we look for intense winds is a bow echo. So when we go from having a line of storms that all of a sudden starts pushing outwards, that's getting this kick of air from behind that is causing it to do that surge, and that wind can get down to the ground. So whenever we see this bow echo, that's a signature that you have some very intense winds that are occurring there. Tornado debris signature, this is a sign that there's a tornado that's producing damage. So this is, again, that Toma tornado from last year, where this is correlation coefficient, the radar image that you're seeing here. Anything that's in these reds means everything's about the same or should be the same size and shape that's falling. When you get these blues and yellows, that's a sign that there's all sorts of different sizes and shape that's occurring within that section there. So if there's rotation and you're seeing that there, that's typically a sign that there's a tornado. So debris is getting lofted up. All the debris is different sizes and shapes, and that's why it shows up like that. So finally, just why does this all matter? Well, when we're trying to make decisions on whether or not to issue a warning, there's three main things we're looking at. What's the environment, what's the radar, and what kind of reports do we have on this storm? So the environment, that's our background. Is it a day where we're expecting tornadoes, or is this a day where there's just large hail that's going to occur? What's our environment looking like for this situation? Radar, again, we're interrogating what we think is happening with that storm and whether or not there is going to be strong winds, or maybe there's rotation in a tornado. What's going to happen there? And then reports. What are we hearing from the ground? What's actually happening there? So in the nighttime hours, we don't anticipate getting reports. So we basically have to rely on what the environment is and what the radar might be when we're doing this. We're putting out warnings. One thing I will say is that there's been times where we are putting out a lot of warnings and we never get any reports while those storms are going on, and it might keep us from, maybe we get to a point where we're like, man, we're not hearing anything. I wonder if there's actually any storm report, any actual hail or damaging winds that are occurring with the storm. So we might take a break and stop issuing warnings just because we haven't had any reports. So just know how valuable that information is, particularly when we get it in the moment when the storms are coming through. So your report might be what triggers us to issue that warning as well. We might be missing one of these things where the environment's not what we're expecting it to be, or maybe the radar signature is not very strong. So we might have one of the two. We might not issue that warning until we get that report as well. So appreciate those reports. They really help out when it comes to letting people know of what bad weather is coming their way.